go ahead and bring up Xcode. Go to File, and then we're going to open the NSString template. Go to Open. Navigate to your folders for samples. Go to Intro Objective-C _ Foundation folder. Go to NSString folder. Navigate to Template. And select the Foundation project. Go ahead and select Open. Now, as you see in this project, this is just a project with a view controller. And we have these supporting files, which are our Hangman. So we're going to do a Hangman app demonstrating NSString. And there's all these features of our Hangman, and then of course the gallows. So let's go ahead and set this up. Select your zip, and it's an empty view. Make sure to select the Utilities pane, and then from there select the label, drag and drop using the left mouse button, drag another label, and then a third label. Now we also need a text box to enter letters for our Hangman game. So drag the text box using the left mouse button. So with your label, double click on there and type in letter. The second label, type in word. And this label, we're actually just going to stretch it a bit. This will be the label for the word that we're guessing. Make it bigger by dragging it. Go ahead and select the label. And of course, this attributes inspector, change the font size to 40 for minimum font size. And turn off adjust to fit. Let's also click on that T icon to make it bold. So now this is where the word that we're guessing will show up. Now we're going to put our Hangman information on here. So grab an image view in this objects list, find the image view, drag it into here, make it fairly large, stretch it, let it stretch, select the image of anonymous gallows.png in this attributes inspector, select image. Now we have a gallows for our Hangman game. Drag one more image view, and this will be the Hangman itself. Make it proportionate to the noose. We'll just resize it so it looks good. Now our image that we're going to get is not Hangman complete. That's one you lost the game, but the Hangman start.png file. And you notice how there's an image clashing here. Let's change our Hangman start, the background, click on the background, change up opacity to something like 30%. That way it looks a little better with our noose. There we go. Now that we have our images and our initial zib set up, let's set up the properties. With this text box, we're going to do one more thing. We're going to make it smaller so it only looks like it accepts a letter. We're going to change the minimum font size to maybe like 20. And we're going to deselect this adjust to fit option. One other thing we want to do is we want to turn off the spell check because that's just annoying in this scenario. So correction is going to be no. So make sure for this text box you have attributes selected. Select no for correction. Go ahead and save this zib by using Command S on your keyboard. Now let's set up some properties to work with these labels and images for our Hangman game. Go to Foundation View Controller.h and let's go ahead and define some properties to deal with our Hangman logic. The first property we're going to create is the UI image view for the Hangman image, because we're going to be updating that Hangman as we lose the game. So this is UI image view, and we're going to call it Hangman image, and make sure you add this property description of IB outlet so that the interface builder, which is the zib, can see this image. Now we're going to add the Hangman label. So go ahead and add a UI label. Name it Hangman word label. Again, that's Hangman word label. Again, that's going to have an additional property descriptor of IB outlet, so interface builder can see it for that zip. And then we're going to make sure that we track it within the app the correct word that we're looking for when we play this Hangman game. So add an NSString property of correct word. And of course, we need to track the number of wrong letters. So we're going to add another property of NSString called wrong letters. And this will record all the unique wrong letters that we have entered in. So it will basically track how well we are doing on the game. We're going to add a few methods as well. Let's go ahead and add those as well right now. So we're still in the header file. Check Hangman letter, passing in the letter to check as an NSString. So first method. So every time we enter a letter into the keyboard, we will check it using this method. And this has all our logic for the Hangman game. And now we're going to add an additional function called setup Hangman word. And this simply, with an NSString of Hangman word, this simply sets up the app with the initial Hangman word information. So we'll go through how these functions work as we go along. But let's go ahead and go to the M file so we can set up these methods and synthesize these variables. So go to the Foundation View Controller.m file, synthesize all of these properties that we added. You see here, we synthesized them here. Make sure that you dealloc them. So if you do not have this void dealloc function or method, selector as they call it in Objective-C, go ahead and add the dealloc function and release each variable that we synthesized here. So now that you have your dealloc function, we're going to go ahead and add our new functions that we had defined in the header file. We're going to go ahead and add those, and we'll talk about each line as we go through it. So we're going to add a check Hangman letter function, and as you see here, we pass in the letter to check. This is a single letter, and the first thing we do is we translate that into a car, and then we loop through using this for statement. We loop through each letter of the correct word, assigning it to a temporary car variable by using the character at index. We grab each letter in turn and we compare it to the letter that we passed in. And this is just a car, so we can compare it using the equal sign. And if there's a match, we make a range at that index location with a length of 1, and then we replace the Hangman word label text with the letter to check using that range. So now that label has the letter that we found inserted into it. And you'll see this in action when we actually run this code. If there is no match, then what we do here is we simply append our wrong letter to the wrong letter string. And then we say, hey, if that wrong letter string is a certain length, we'll update this image of the hangman. So if we had 5 letters that were wrong, we would based on the length of this string, we would display the Hangman 5 image. Now, obviously, if the user enters the same wrong letter twice, we don't want to record that as an additional wrong letter. We just want to ignore it. So that's why we do the string by replacing occurrence of string first, so that anytime we might have a duplicate letter, we just replace it with a blank in this wrong letters, and we start from scratch here, and we add that wrong letter again. So that solves that problem. Then to set up the Hangman word, we pass in the Hangman word into this function, our method as you would call it. We make sure to reset the wrong letters in case we had been playing this game a couple times. We reset the label text to empty, and we reset the image of the hangman to the hangman start. And then for each letter of the Hangman word, we add to that label a symbol so that we can see in that label how many letters we're looking for on Hangman. So we go through the length of the Hangman word that's correct, and we just assign to that label a special symbol so that we know how many letters we're looking for this word in Hangman. And that's the setup of the Hangman. And of course, this other one was the checking the Hangman. Now we have nothing set up yet to fire any of these functions. They're just added to this view. So let's go ahead and set this up. Now uncomment out your view did load, and we're going to add the setup for this. Now our correct word, we're just going to hard code it in this app. Our correct word we're searching for is Colorado. So we're going to assign the correct word to Colorado, and then we're going to set up the Hangman by passing in that correct word to the setup Hangman word function. And this is all in the viewDidLoad method. So when the app is first started, when this view first loads, it sets up the correct word as well as the Hangman word setup. And our second option we need to do is when they enter a letter, let's go back to our zib. They're going to enter a letter into our text box, so we need to account for that. Whenever they enter a letter in that text box, we want to fire the check letter event, our function, check Hangman letter function, to test for it, test for Hangman. So let's go ahead and set that up. If you go back to the header file, we're going to set up a delegate to trap the UI text field. So go ahead and add a delegate method. UI text field delegate is added as a delegate responder, our protocol, right here on the header file. So now this Foundation View controller will be able to override methods available to UI text field. So let's go ahead and add the UI text field methods that are available to us by responding to that delegate. Go back to your M file. Go ahead and add the text field should change characters in range. And of course, this is a UI text field method that we're overriding, and we're allowed to override it because we're saying that we're going to respond to this protocol, our delegate. So we have this method now available to us on the text field. And what happens here is when they enter a text field, or actually when they type in a letter, this method is automatically fired for our text field. And so we check the Hangman letter function, passing in the replacement string, which is string in this case, and we return no. And the reason we return no for this should change characters in range is each time they enter a letter in this text box, go back to the zib, we want that letter just to disappear. We're not going to add to it or anything for our display purposes. We're just going to have it disappear, so that's why we return no. Otherwise, you would return yes, because they would be allowed to change that character there. Now, one additional thing that we're going to add here is we're going to add the text field resign first responder. And what this does is it actually hides the keyboard. As soon as they press a key in here and we say we do not accept changes in this field, we'll return no. The keyboard would still be visible if we did not have this resign first responder. So now when they enter a letter, a resign first responder actually closes the keyboard for us automatically. And I'm going to add one more function for your use, and that is text field should return. And what this does for us is it says resign first responder. If we had this commented out, resign first responder in our should change characters in range, if they hit the return key, nothing happens unless this function here is added to our view, which actually resigns the first responder. And we could see that in action, but I think you get the point that do keep this in mind. Text field should return needs to be available on your any text field that you have rely on the done button. You need to implement this resign first responder. In our case, we're fine because we're just going to resign first responder in the should change characters in range. In fact, this function does nothing for us in that case, but in the future you will run across this scenario where you need to click that done button and it does nothing for you unless you implement text field should return. Now we need to set all this. We added all these properties, but now we need to set it up with our zib and associate it. So go back to your zib, click on letter, word, label, and click on the utilities pane. And if you click on this main label here, we want to associate this with our label on our header file. So make sure you have connectors selected and left click on the referencing outlet and drag it over to file owner, and you have Hangman word label available. Click on that with your left mouse button. Now we have this label associated with our header file, and our Hangman we want to associate as well. So go ahead and click on your Hangman image. Make sure you have connections icon selected. Left click on the referencing outlet, drag to file owner, and select Hangman image. Now for our text field, we need to do a couple things. One is we need to make sure that the delegate is set up so that when the user actually presses the button, that this text field is actually associated, those events are associated with our header. So grab that delegate, make sure the delegate is associated with the file owner. And you do that by dragging the delegate of this text field and drag and dropping it left click onto file owner. So now the delegate, any text field events are now associated with our foundation view controller.h. One more thing that we do want to do, go back to attributes for that text field, and let's make sure it has all the right options available. We turned off the correction is no, and it looks like we have capitalization set to none as well. In our keyboard, we want to change to just a name phone pad because we're just dealing with letters in this case. We don't need the numbers. So change it to name phone pad for the keyboard, and we should be good to go. Go ahead and click run and see what happens. And now we see that we have our app available. We're going to enter a letter of Y, and you see that the Hangman starts. K is also a wrong letter. D is a correct letter, so it shows up. C is a correct letter. O is correct. Let's try Z. And Z gave us another wrong letter, so we're getting closer to Hangman. And once again, we're closer to Hangman. And as you see here, this image is updated as we're doing the check letter function. The image is updated with a new image based on the length of wrong letters. Let's go ahead and view some of this code again. One thing I want to make sure you have in mind is that when we replace that label, we're replacing the range that we found the correct letter at with the string letter to check. So the correct letter is replaced using this found range here. So that label is updated. And when we first set up that label, we set it up with the special symbols based on the length of the correct word. So that's why we have these special symbols available to us. And if you examine the source code in depth, you'll understand how useful NSString is. There's a lot going on here, but it demonstrates a lot of the capabilities that you can do when working with strings. And you can cast strings to car variables to compare. You can basically insert a string at a particular range, and you can find those ranges as well by looping through the cars. And you can replace occurrence of strings. And you can append strings as well by using the string by appending string function. And that concludes the introduction on NSString.